the phenomenon of the superconductivity was discovered by Candee in 1911, and after that, British physicist B.D. Josephson in 1962 he postulated that whenever two superconductors are separated by a thin insulating layer, a supercurrent flows that is given as IS is equal to IC sin phi, and whenever you apply some external voltage, then this phase phi, which is the phase difference across the two superconductors, is actually evolved with time and given by this equation. So now you have a AC current which have frequency of this much 2 eV over mesh cross. Later it was also known that whenever this insulating layer is actually replaced by such kind of weak links, and when the order of this weak link is of the order of coherence length of the material, then also one can observe Josephson effect. So I will. So when I say conventional squids, they are conventional devices. Then there is a insulating layer, and when I say weak link, then it is like such kind of structure. So these are conventional devices, and this is the device that I made in this work that I am getting here. So conventional squids actually follow the basic principle of Josephson effect and flux quantization. So here you have two such Josephson junction as shown earlier, that is in a loop, and when you flow some current, there is a bias current, the current is redistributed into branches, and then when you apply some active flux perpendicular to this loop, then what will happen? This current actually constructively or deconstructively interfere, and then you see some kind of oscillation. This kind of oscillation, which have a period of the order of phi naught, which is flux quantum, and it is actually of the order of 2 into 10 minus 15 Tesla meter square. So, and there are many more points in between as well. So you can assume, you can see that how sensitive these reactors are magnetic flux. So squids are actually the best known reactors of magnetic flux. And in conventional squids, actually, if you want to characterize some sample, it is actually kept in a pickup loop, and then by an inductive circuit, your sample is coupled with your squid device. But suppose you want to characterize some isolated single nanoparticle, then this is not a perfect tool to measure isolated single nanoparticles, because here the coupling is indirect, and there may be bias at each level. So to avoid that, and if you want to measure isolated single nanoparticles, then the detector should be also of the same size, and if there is coupling, there is that direct coupling, then that will be better. So here comes nanosquids, which is a proof for nanomedicine. So here a typical squid characteristics are mentioned, like most widely used material are magnesium and aluminum, and the technique used are electron beam lithography and focused ion beam technique. And the diameter, as I already mentioned, is of the order of micrometer, 1 to 4 micrometer, let's say, and this junction dimension is of the order of, so here one junction is here and there is here. Similarly, so this is of the order of coherential length of the material is like 50 to 100 nanometer, and the flux resolution in such microsquids is of the order of -5 phi naught per square root, and people have tried even better, and in current date, the best known squid has resolution of 10 to the power -9 phi naught per square root. That is the best till now, and these are the recent applications of microsquids that it can be used for magnetization reversal of an isolated single nanoparticles, scanning squid microscopy, and then nanothermometry using squid on tip technique. So these are actually best known temperature sensors as well. So here you can see that this particle is coupled directly on top of the squid arm, and here it is a nanoparticle, here it is a nanowire, and this is like some quantum dots on dots of nanoparticles deposited using some techniques. So there are some problems and challenges as well, that these are limited to very low temperature. So we are limited by the TC of the material. So for niobium it is like 10 Kelvin, for aluminum it is like 2 Kelvin or so, and for high DC superconductor close to 90 Kelvin. So we are limited to very low temperature, so it will work below TC only. This is the limitation. And in IV characteristics, we do see hysteresis for such weak link based devices. So here you see that this is voltage versus current is plotted, and till when you ram the current, then the zero voltage state is there till some particular current known as IC. So this point is known as IC, that is critical current, and when you ram it above, you are in ohmic region, but when you ramp it down, then we do see hysteresis in this IV curve, and we don't get to zero voltage state at the same IC current, but some lower current known as retrapping current IR. So this hysteresis, the reason of hysteresis in these devices is found to be Joule heating, and that was experimentally verified as well by our collaborators from France. So this hysteresis, because of Joule heating, actually is disadvantageous, because nanoparticles kept directly on top of the device, and if there is some Joule heating produced inside the device, so what will happen, the bath temperature will be different and the local temperature will be different, so you will not be able to get exact characteristics of the device. So it is actually a disadvantage, and it also increases the measurement time, it decreases the sensitivity and so on. So hysteresis is a disadvantage, and we want to get rid of that, and we want a non-hysteretic nanosecond device down to 1.3K. That is our goal. So I think goal is focused. So here on device fabrication scheme. So we have made some devices using electron beam lithography and reactive ion etching technique. So I can discuss it later maybe if someone have interest. So this is the devices that I made. So this is you can see the full silicon wafer and so many devices. This is the zoom of one of them. Like this is SiO2 coated acid substrate, and I have like here 5 devices. So if you zoom one device and you zoom, let's say here, so this the zoomed portion is like that one. So I have a nano split in this region, and if I zoom it further, so this is like that one. And these are some shunt resistors that I will explain later why it is used here. So I will now come to some of the results that is published here in Physical Regulator. So here we played with the weak link dimension. So let's say right now weak link dimension is fixed, and addition to the weak link there is this narrow leads, and then there are wider leads as well. So here wider leads are shown here. So in R versus T curve, we do see different TCs. So like TC2, that is TC of the bulk leads, that is quite close to the bulk niobium. This is around 8.9 Kelvin, and the weak link structure has actually even lower TC, and as shown here, it is like around 8.4 K. So this is actually the TC of these narrow leads, which is addition to the split. And TC of the weak links are even lower, and that I will discuss that it is around 7 Kelvin. That I will discuss from IV curve later. So here one can assume that this is IV curve, and one can assume that this is the resistance of the loop, and then R1 and R2 are the resistance of narrow leads, and R2 is the resistance of the wider leads as well. So here I1 of the IV curve is plotted at 4.25 Kelvin. So here this is IC. But when you ramp it down, I do see 2 retrapping currents. One is IR2 and one is IR1. So by using a thermal model, we explained it in terms of Joule heating in first leads, that is IR1, and Joule heating in the wider leads, that is IR2. And we have captured IC, IR2, and IR1, the temperature dependence of the all three, and discussed the device diagram in that manner. So what we see that IC actually varies linearly with temperature. That is consistent with the earlier known theories. IR1 and IR2 have square root dependence. So here IC is governed by superconducting properties, while IR1 and IR2 are governed by Joule heating properties. So here the behavior of all the three is actually different. So this is like square root dependence. This is also square root dependence, and this is linear dependence. But this crosses IR1 at a temperature known as crossover temperature. Okay, so above this crossover temperature, this IC actually has changed its slope, and this change in slope is actually regarded as because the TC of this weak link, that should be, if you extrapolate it, and it should go to 0 at this temperature, which is around 7 Kelvin. But TC of the weak link is not 7 Kelvin, but it is like close to this TC of this narrow leads, which is 8.4 Kelvin. So in this regime, actually, because of proximity effect, these weak links is still superconductor because of the proximity effect, and that's why this IC in this region had actually changed its slope, and it is still varying linearly but this goes to 0 at higher temperature known as TC of the adhesive structure. So here proximity effect as a role, and your effective non-static regime that should have been from 7.2 to here, but it is now enhanced from this TH to around 8.4 Kelvin. So we have we play this dimensions. So what will happen if you play with the dimension? Then IC actually scales with the weakling dimension, and this IC is still very linearly, but have lower values. You see, it is like at 4.2 K, it was 1.3 milliampere. Here at 4.2 Kelvin, it is around 0.8 or 0.9 milliampere. So IC actually scales with weakling weight. I reduced the weakling weight, and I found that this IC value has reduced, but the slope is still linear, and it crosses. I didn't change the other dimensions, so IR1 and IR2 values are same. So it crosses the IR1 at even lower temperature. TH, that is now around 6.5 Kelvin. So I have a larger window from 6.5 K to 8.5 K, which is non-hysteretic. In this region, there is no hysteresis, that is, there is no Joule heating, and devices are better and can be operated in this range. So my idea is how to reduce TS to down to 1.3 K or the lowest possible temperature, so that we can have a wide window of from 1.3 K to, let's say, to the TC of the material. So that is my main focus. So that we did by choosing the specific weakling width and using some shunt resistor as well. So here in the result, we put a parallel shunt resistor quite close to this superconducting anode device or weakling device, and what we found that this retrapping current actually, because we haven't changed the weakling structure, we haven't changed, so IC is still same, but the normal resistance values have changed because of this structure. So here you see the gold shunt resistor. So we in one case we measured this device with gold shunt resistor, and then we removed this gold shunt by chemical etching. The other part is actually iridium, and this is gold. So we just etched the gold. So gold is now removed, and we got this bare device. So we characterized this bare device and the gold shunted device and compared the characteristics of the two, and we found that IC is still very linearly with temperature, as earlier discussed as well. But the values of IR1, which was for the unshunted one, the IR1 value is quite around 0.3 milliampere, while for the shunted device it has increased by a factor. So we have it varies still square root dependence, but this IR1 actually has increased by a factor. So now the crossover temperature is even lower. So this window of non-static regime is actually enhanced, and if you and we also got quite good speed oscillations in this range in one device where you see this non-static IV curve. So there is no, so when you ramp up, it goes like that. This one is IC, and when you ramp down, it again comes follow the same path. There is no hysteresis in this device. So by choosing particular weakling dimension and the shunt resistor value, we found that the device is non-static, and we could see the quite good speed oscillations, and this period is of the order of flux quantum phi naught. If you compare phi naught is equal to B into A, so one can find out the area of the speed loop. This is 1 micrometer by 1 micrometer, so 1 micrometer square. So that was consistent with our measurements. So in
maybe in 1 more minute.
Oh, sure. Okay. So we reduced the weakling dimension even further and got devices that are non-static even down to 1.3 Kelvin. Okay. So these are some results where SNS-based devices, the speeds which have so here you can see the different voltage oscillations and different bias current, and one interesting fact we found that if you redraw this IV curve and extrapolate it to this x-axis, so that current is known as excess current, and this excess current we found that actually has this kind of dependence, and here delta is the superconducting order parameter delta. So if I plot this I minus V by Rn, if I plot it for all temperature ranges, so I found that it follows almost a square root dependence. So one from excess current, one can extrapolate the order parameter of the superconductor. So it is actually a probe. Excess current is actually a probe for superconducting order parameter as well, and it is consistent with the BCS values of superconducting at delta at quite close to 0 Kelvin. So this is the conclusion of my talk. For the first time, we see that the critical current switches from classical behavior to one driven by proximity effect, and this enhances the non-static regime. And we also got devices down to 1.3 Kelvin by using a particular set resistor and by with the weakling dimension. And these are very significant in designing these micro devices for better performance and probing nanoscale magnetism. And the axis current is also proved for superconducting order parameter that we discussed. So a viewpoint was also by Christopher Bell, a viewpoint was written on my article. So that's all. Thank you for your patience. And these are some of the projects that I am handling right now. Over 62 lakhs, one by DST and another by IUC. And this is from UPCST. And this is my lab that I have developed right now. So this is low temperature setup that I have developed, and some nanoparticle synthesis laboratory. So if anyone is interested, then you write to me. Thank you.
So maybe since time is short, maybe one quick question.
Below TC only, otherwise it's a carbon metal. So, but till now, this high DC superconductor, like YDCU, can go up to 90 Kelvin. So this setup is for YDCU basis only. So we can pressurize it down to liquid nitrogen temperature. So people are now trying to enhance the TC of the material. So like pressure induced superconductivity has been achieved around close to 200 Kelvin, but people are still trying to get high room temperature superconductors. That question is still on, and people are still trying.
In the graph, there are two PC zone. So,
Yeah.
Is it true that
No, one was for bulk leads, that was narrower. The DC was quite close to the bulk diameter, and other DCs for the narrower leads. The narrower leads, that because with the narrowing the dimension, this other parameter gets suppressed, and DC is also different. Yeah.
So, okay, so maybe time is short. So thank you very much. So let us thank the speaker for a very nice and interesting talk.
We would like to present a memento as expressing our gratitude toward our speaker. Thank you so much, sir. Now, may I request our Honorable Session Chair to kindly introduce us to the next oral presenter.
So now there will be two oral presentations. One is Dr. Amita Singh, and you have total you have 10 minutes. So that means 8 plus 2. So I would request that you concentrate on your results, finish within 8 minutes so that one can ask questions also. So after 7 minutes, I will be standing.
Good afternoon to everyone. I am Dr. Amita Singh, Assistant Professor in Department of Chemistry, Dr. Ram Manohar Lohia, Awadh University. As I think nowadays everyone is aware with the
solar energy. And among the all generation of photovoltaic devices, the third one, that is a dye-sensitized solar cell, is more leading and captivating. So it is a little introduction from last 30 years of dye-sensitized solar cell. As I have told, the third generation of photovoltaic devices, the dye-sensitized solar cell is more advantageous over the silicon-based solar cells because of its lightweight, color property, flexibility, and greatly shown efficiency up to 15.2%. Okay, the important point of in these photovoltaic devices is the sensitizer, which is playing a major role. In this regard, azides are a peculiar class of compounds containing nitrogen-nitrogen bond having alkyl group. These alkyl group may be different or the same to produce an asymmetric system. Here we have incorporated two different functional groups, phenolic and nitro anchors, to assess the suitability as the anchor in the titanium dioxide, and the results of this investigation are here. And this is the synthetic pathway which I have followed to prepare the sensitizer, and this is the single crystal X-ray structure of a sensitizer FCNO2. And as we can see that from the carbon 11 to carbon 12, here is a not highly, but a efficient conjugated and planar system is obtained. And to study the optical properties, the first I have recorded solution phase electronic absorption spectra, and second, the obtained solution phase electronic spectra is overlaid on the surface of the titanium dioxide, and in the solution phase absorption spectra, a band recorded at the 506 nanometer for FCOH and near to 474 nanometer for FCNO2 that can be attributed to the DD transition of the iron present in the thyrosine and the orbital of cyclopentadiene ring. And another strong band observed at the 326 and 230 nanometer is in both sensitizers is due to the charge transfer transition. And the medium intensity band observed in the region of 470 to 506 nanometer is an evidence to make these molecules as a suitable sensitizer to use in dye-sensitized solar cells. And another one, to study the electrochemical properties of the synthesized sensitizers, we have performed cyclic voltammetry. This is the obtained cyclic voltammogram. The upper region of cyclic voltammogram is presented, the oxidation potential, and the lower portion of the cyclic voltammogram presented the reduction potential. From the value of onset oxidation potential and reduction potential, we have used to construct the energy level, the HOMO energy level in the HOMO energy level, and to construct the LUMO energy level in the energy level diagram. We have taken the value of, here I have missed the mu after H mu value of the sensitizer obtained from electronic absorption data and redox potential value. And this is the constructed energy level diagram, and this is the electrochemical properties of the sensitizer. Here delta E and E naught is calculated, and EPA and EPC is obtained value from cyclic voltammogram. And from the energy level diagram, it indicates that the HOMO energy level of the both sensitizers are in positive position in comparison with the redox coupled iodine and iodide, while the LUMO energy level is on an efficient negative value in relation to the iodine and iodide redox couple. The position of these HOMO and LUMO energy levels indicates that both sensitizers have better electron injection property in the conduction band of titanium dioxide. And to further study the efficient electron injection mechanism in both the sensitizers, we have used some computational calculation, which is density of state plot, and from the DOS plots for both sensitizers, we have obtained the occupied localized state, and also we have compared the occupied localized state of both the sensitizers with the position of valence and conduction bond of titanium dioxide nanoparticulate, and further we have overlaid the plots of titanium dioxide nanoparticulate with the plots density state of plots of both the sensitizers. And from these plots, the information is resulting that both sensitizers, then excitation of lower energy electrons from valence bond, which is located at -8.2 to 5.6 electron volt to the conduction band at above -4.2 electron volt. And the calculation revealed that minimum band excitation is are 0.75 electron volt and 1.22 electron volt for the both sensitizers. The minimum excitation energy band is also a very strong evidence that both sensitizers are displaying a major role to enhance the dye sensitized solar cell efficiency. And these are the photo X-ray spectra of the sensitizer. And this is the IPC. First one is the incident photon conversion efficiency spectra, and another one is the potential and current spectra, and this one is the Nyquist and Bode plot. Nyquist plot is used to study the electron surface resistance, and the Bode phase plot is used to study the effective lifetime. And we can see that in both the plots, the performance of sensitizer FCO, which is greater than FCNO2. And another one is the ATCE. ATCE is also shows that if the performance of FCOH is more better than with more acquired photon conversion efficiency, which is about 60% in comparison to the FCNO2 sensitizer. So the results are used to compare both the sensitizer in comparison to the state of the art and 719 dye, which is a radium based dye. And another one is the open circuit voltage decay curves. These curves are used to study the effective lifetime of both the sensitizers. From these curves, the information obtained that the decay phenomena of FCOH is slower in comparison to the FCNO2 sensitizer, and the decay rate of FCOH makes it more suitable in comparison to the FCNO2. And another one is the lifetime studying plot, and which is also in support to the better photovoltaic performance of FCOH. And last but not the least, I am thankful to university where I am working in the capacity of assistant professor, and the Department of Chemistry, University of Lucknow, where I have completed my PhD and also conducting my research. Thank you very much.
Okay, thank you very much for speaking on time. Okay, so questions.
Oh,
Yeah.
Another question?
Yes.
We have 2 minutes.
It's okay.
okay. Actually, I was.
So how much is the efficiency of this?
Actually, the efficiency of both the sensitizer was near to 5.5 to 5.4%, which is very close to the, as I think you have heard about the N719 dye, which is a ruthenium based dye, which is the state of the art. And the recorded efficiency of that dye is above 5.5%, 5 to 6%. So both sensitizers are near to that dye.
Actually, calculated efficiency is about 40.
Okay.
So I think.
Actually,
can see
efficiency in the form of eta, 4.5, 3.4 in that form. IPCE in the form of percentage.
Okay. Another one is how you have assured that is DD transition in your case.
By calculating the value of value obtained from the electronic absorption spectra, and by following the reports mentioned in previous reported literatures.
How that will tell us that it is DD transition? Means D orbital DD transition.
DD transition is iron present in the ferrocene moiety.
Can you go to your
Because iron is in the
your energy diagram? Yeah. That another.
Okay.
So this is right. So your you have written homo.
Yes.
And lumo is there.
Huh.
But they are at different places. You can see the structures,
Huh.
the isosurfaces. One is on ferrocene, homo, and lumo is located on the your another tail part, right? So DD means it should be on same, right? Your ferrocene ring. So
Sir, ferrocene ring is present in both the compounds, but
No,
the entry group is different.
I am
Listen to the
talking about only one
Listen to
compound.
the
Don't take any one compound.
Okay.
So there is DD transition in same compound, right?
Yes, sir.
So that HOMO, if it is a HOMO to LUMO transition, then that molecule orbital should look at same place because that atom is there inside the two rings. It should not go to other side. So I think it's that
Follow the
maybe.
question. Follow the
I hope you
question.
got my point.
I'm just getting confused about
I
the
just
question is saying about the position.
Maybe you can, if you have time, you can discuss
Yeah.
with
Yeah, I can discuss it
Maybe-
later. This,
She's also in a hurry. She has a
Yeah,
bus to
yeah.
catch in the evening. But you should talk to him because this point is important. Because
Okay.
Homo and
Yeah,
Homo,
because
what
you are
we
saying DD transition, but
Mhm.
in your figures, that is not looking at DD transition.
Okay.
Because D orbital will be there on your metal only, right?
Mhm.
So, but two molecular orbitals, they are looking at different places.
So
Not on same metal.
actually, this is the energy level diagram,
No,
which
no,
is
you have written
which is,
plotted the figures, na? So,
plotted by using the data obtained from cyclic voltammetry
oh, they,
and Gauss calculations. DD transition is
the
just
graphs
to
are from cyclic voltammetry or from some software you
Yes,
are
sir.
plotting molecular orbitals.
from by using
Gaussian or something.
Gaussian and Gaussian. Yeah. So the transition is we to assess the transition type of charge transfer, we use to record the solution phase absorption spectra, and all as we know while designing the scheme, we incorporate those molecules, those metal
Okay,
centers.
we'll discuss
I
maybe
think
afterwards.
Okay.
First.
you have
And another one just for this. Normally, HOMO values are negative and LUMO values are positive, but in your case, it's opposite.
opposite.
So maybe that also we will discuss.
Yes.
Okay,
If
sir.
you
Okay.
That is
Thank you, sir.
completely confusing.
हाँ,
Okay, so let us thank the speaker again for a very nice talk and for finishing on time.
Yeah.
Okay, so next another talk, oral presentation. I don't know whether he or she is here. The next talk is by S. Dokwal. S. Dokwal. Missing? The thesis also Monica is here. Okay, so we will start on the thesis. Okay, so next is the thesis presentation. Monica Srivastava, faculty in Bennett University, Noida. So, Monica, you have total 15 minutes. No, 15. Yes, 15 minutes. So you finish by 13 minutes sharp. I'll stand. Then 2 minutes for questions. So you only concentrate on your important results. Okay?
So good afternoon, everyone. I'm Monica Srivastava, visiting assistant professor at Bennett University, and here I'm presenting my thesis presentation on computational investigation of nanostructure materials as sensor for the carcinogenic elements in water and air. This is the flow of my presentation. I start by introducing my domain of research and then discuss the research gaps and objectives that I have identified. And then I will give the methodology that I have adopted. And finally, conclude the presentation by giving major findings, that is results and discussion. So this is a brief introduction. As my thesis title suggests that it is related to something about environment and its start. So first we understand what is environment. It is everything around us, and hazards is source of potential damage. And pollution is hazardous to the environment. Everyone knows this thing. So, and they are of different types, and we are focusing on the water and air pollution. So these are the major categories of water and air pollutants. And among them, we are focusing on the heavy metals which are carcinogenic in nature, that is arsenic, cadmium, chromium, mercury, and lead, and carbon dioxide, which is co-carcinogenic in nature. And these are the some reports which tells the scenario of air and water pollution among in India as well as abroad, and tell us that the concentration of heavy metal as well as the carbon dioxide has been increasing day by day, year by year, and has adverse effect on the human being, even has carcinogenic effect on human beings. So we require sensors for them to monitor and control. And nowadays, various sensors are available, sensing techniques are available, but they have their limitations that they are costly and they suffer from degradation of the electrode, require sample pre-treatment and so on. And the camera resistive sensors plays important role in them as it offers various advantages. That is, it is low in cost, improve sensing performance, and most important, it promotes lack of chip concept and real-time detection. So, as we all know, that in the chemical resistive sensors, channel material plays an important role. So, we use this one-dimensional, two-dimensional material as a channel material in them. And I think as I have two categories of pollutants, so I organize my thesis in two parts. First section is based on detection of carcinogenic and heavy metals into via 2D and 1D materials, and second section based on the detection of carbon dioxide through one-dimensional, two-dimensional material. And this is the methodology. In this, after completing my literature review, we have modeled different structures, analyzed them for their energetics, and if they have found interaction stability, then we go for their sensing abilities in terms of electronic properties and the transport properties. And if we get variation in the transport properties and the electronic properties in the presence of the analyte, then we pursue for the sensing parameters, and on the basis of that, we decide whether it is suitable for sensing or not. And these are the sensors that I have identified during my research period, the literature review, that this chemical system test sensors are not explored for the detection of water pollutants. It has also found that the graphene has explored for detection of heavy metals, cadmium, mercury, and lead, but its sensing ability for the detection of heavy metal is not being explored. And literature also reveals that the impact of graphene functionalization has not been explored. So I have tried different, basically I have proposed an objective for that for different functionalization. And in terms of one-dimensional material, it is examined, the literature examines the effect of different morphologies of zinc oxide nanowire in graphite phase, but its effect on zinc blende phase was missing in the literature. It is also found that the sensing application of these different methodologies of zinc and zinc oxide nanowire was not explored yet. And these are related to the air pollutants, that copper decorated boron nitrogen functionalized graphene has been explored for as a catalyst and shows good health performance, but it is not explored as a sensor for the carbon dioxide. And sensing application for different these model zinc and zinc oxide nanowires are not explored for this carbon dioxide detection. And these are the objectives that I have proposed. We will discuss later one by one. And this is the computation methodology that I have used in my research work, that I have used quantum ATK tool and following accuracy parameters. Along with that, I have calculated these performance and analysis parameters for my research work. And moving to the objectives first, which is basically aim at exploring the stability of the graphene monolayer as a sensor for carcinogenic heavy metals present in water as pollutants. And the major finding of this is that we can use the pristine graphene as a chromium detector, as it has shown highly response of 82%. And this is the work under which we have modeled the pristine graphene and tested and investigated it for different absorption of this, different heavy metals at these different sites. The C is at the top of the carbon atom, and P is which of this side of the carbon-carbon bond, and H is hexagon at the center of the hexagonal ring. And we have found that the chromium is the most stable and most energetically stable site of absorption for chromium is hexagonal site. And energetics reveals that the chromium is absorbed on the surface of a pristine graphene, And to see the sensing ability, we have calculated the electronic properties, and the brand structure reveals that then on exception of chromium, this pristine, the semi-metallic nature of the pristine graphene, you can see the conduction band edges and the valence band edges shift towards the Fermi level, and this is also validated by the plotting the density of states and the projected density of states, which reveals that these additional peaks due to shifting are due to the chromium d orbitals. Then to validate our result further, we have calculated this transport properties in terms of current voltage analysis, which reveals that there is division in current, which is further corroborated by plotting the transmission probability, transmission spectrum, as well as transmission eigenstate, which reveals that in the presence of chromium, the transmission probability decreases, and due to this backscattering of the electronic states. And then we to realize our result in more practical with more practical approach, we have did all the calculation in the presence of water, which reveals that again chromium is can be solved on the surface of pristine graphene in the presence of water, but interaction between them is reduces as the absorption energy reduces and the charge transfer is more in terms of this absorption energy. And then we have computed this sensing ability, and we have found that the in terms of band structure, that the pristine in case of water, in the presence of water, pristine graphene does not show any difference in the electronic band structure. That means it is semi-metallic in nature, but on absorption of chromium, it shows an introduction of band gap of 0.22 electron volt. So we have displayed this thing with this comparative analysis. In this case, pristine graphene is similar. This is the black graph is for the pristine graphene in vacuum, and this is chromium absorption in the presence of water. That so this shows that the presence of water basically introduces a band gap of 0.22 electron volt. Then we have computed the current voltage analysis again in the presence of water, which reveals 82% of response towards this chromium. So, and also we have did the cluster, see the clustering effect of heavy metal, which reveals on the sensing ability, which reveals that this detection range as well as the operating voltage reduces on increasing the number of this chromium atoms. So basically, we can say that by these results, the chromium atom, the graphene is suitable candidate for detection of chromium. Now moving to the second objective, this says we basically analyze the impact of functionalization of graphene on the sensing of heavy metals. And we did functionalization with boron, nitrogen, transition metal, copper, nickel, and zinc, and also did decoration of copper on the functionalized graphene. And these are the findings. Basically, functionalization improves the operating voltage and also response of the sheet while doing different loadings and functionalizations. And these are the results we did in the same manner as we with the same approach as we did earlier. And we have observed both in even vacuum and the viscous environment, and we have observed that the boron graphene can detect arsenic, chromium, and lead with the response of 3%, 54%, and 17% with low protein voltage. And in case of lead, we have also achieved fast recovery. Similarly, for the nitrogen functionalization, we got the same the results in the same manner, and these are the results. It shows that the this nitrogen functionalized graphene can detect all these three heavy metals with lower operating voltage and with relatively high response and fast recovery. Again, we did this copper functionalization as well as nickel functionalization and also zinc functionalization. All of the results reveals that we have good response for the arsenic. All the transition metal has good response towards arsenic, chromium, and mercury and lead, along with a special thing is there that the mercury has high recovery rate also for all these things, and all the results are have low operating voltage. And again, We have also tried copper decoration on nitrogen. Basically, we tried on both boron and nitrogen functionalized graphene, but these results are better. So we have observed that the copper decorated nitrogen functionalized graphene can detect arsenic, chromium, mercury, but in case of lead, it gets distorted. So it can detect almost well with high response and low operating voltage. And this is my third objective, which is basically based on the modeling of different morphologies of GPO and oxide nanowires and explore them for the detection of heavy metals. And in this, we have modeled three geometries. This is rectangular, square, and rectangular, and observe that the rectangular one is the least stable, and square is the most stable. And by analyzing the band structure, we observe that this rectangular and triangular are semiconducting in nature, and this square one is basically metallic in nature. And this is my fourth objective, which is based on analyzing the copper corroded boron and nitrogen functionalized graphene for the detection of carbon dioxide. And in this, we have this major finding that we have a variation in the band gap of 0.07 electron volt almost, and when we calculated the response, it comes to be copper decorated as 55.91% with fast recovery, and copper decorated nitrogen with 78.99% 25.8 milliseconds with recovery. And it is higher than 26% for the which we have in the literature for the pristine graphene. And this is the objective fifth, which based on the analysis of the suitability of the model morphologies of zinc and zinc oxide nanowire for the detection of carbon dioxide. And in this, we get best results for the rectangular wire. And in this, we have got variation in the electronic properties as well as the transport properties, and observe that with the response of 18% with fast recovery of 5 microseconds. And all these are the summary of the heavy metal detection that shows the functionalization basically improves the response of the devices as well as the lowers the operating voltage. In some cases, we have found this basically the shorter recovery time. The advantage of shorter recovery time that they can be used as reusable sensors. And best cases we can use, but they are disposable sensors. Similarly, the case this is the summary of your carbon dioxide detection. So in this we get this maximum response for the copper decorated nitrogen functionalized graphene. And in conclusion, we for the heavy metal detection, we have found that the pristine graphene can act as a potential candidate to detect heavy metal chromium, but it has a limitation of high operating voltage of 400 millivolt. And then functionalization of graphene improves the device performance in terms of response and lowering the operating voltage. And we have got maximum response for the copper zinc functionalization through copper, zinc, and nitrogen to detect arsenic and chromium for the case of copper, zinc for the mercury, and nitrogen for the lead. And it is compared to the other pristine case as well as proposed 1D material. And for the CO2 detection, we have found that maximum response can be achieved through functionalization of graphene via copper decoration of nitrogen functionalized graphene compared to the other pristine parts and one-dimensional materials. And this is the future scope. We can extend our work to detect the same proposed sensing elements for the detection of heavy metal in ionic state and the complex state. We can also see the coverage effect to understand the impact of heavy metal clustering on the sensing ability. We can also see the impact of dopant concentration on the sensing abilities of the proposed materials. We can also try to see the selectivity of the sensors by introducing different species. And this is the additional work that I have done. I have tried copper decorated nitrogen graphene as a catalyst for the Higgs reaction. And this work is done in collaboration with this experimental group. And these are the publications that I have published during my research period. It is almost 8 in numbers and with consolidated impact factor of 25.38. And these are the significant achievements. And I would like to thank our institute for giving me the infrastructure for doing my research. I would like to thank my supervisor for his valuable guidance and support. And I would also like to thank our director sir and SRC member and also the PhD coordinator for their suggestions. And I would like to thank CSIR for giving me international travel card to travel Australia to present my work at global level. And I would like to thank MHRD for the giving fellowship for my during my research work. And at last, I would also like to thank our group and collaborators. Thank you.
Thank you very much for finishing almost in time. Okay, so now open to questions. And since it is a thesis presentation, I would request the audience to ask critical questions.
Ma'am, you have already asked me.
I can still ask.
No.
I will ask.
Yes.
I will ask, not wait question. So in water, how earlier case, in water, how your device is working? Is it working better way or?
Sir, it is working, devices are working, but the thing is, it requires sample pre-treatment and collection of your water in some, if you do the exact accurate this sensing. But let's say if there are colorimetric sensors are available, you can do on-site detection like using color. But they sometimes use false results.
So what I might say, you have done your theoretical work, right?
Yes.
Computer simulation you
Yes.
have done. So you have done with, I have seen one water molecule and in one slide you have shown few water molecules.
Yes, this
Right,
is
so,
a.
let me complete my thing. So what is the difference means in one water molecule and more water molecules? So in which case device is working better?
Actually, sir, we for this more number of waters and more number of focus, we have did this thing with the perception of increasing heavy metals on the this sheet basically. So, ma'am has suggested me for my future work, you can do this with the number of water molecules. So that result I still need to do things. But for the case of that, we have got better results because it improves the increased
more
number of water molecules along with increased number of chromium atoms because we have more again less operating voltage and also we have more detection range for
So
that.
you can see difference in less number of water and more number
Yes,
of
we
water
can
in your
see
device
definitely.
reading, right?
Yes, because at that time more things what this hydrogen bonding and comes into the picture, lots of things come into the
So
picture at
maybe
that time.
I'll suggest also maybe we can look at
Yes,
humidity sensing of your device.
exactly. We
Because
have
if you
to.
increase 0 to 100% humidity,
Yes,
and if you will get better thing, maybe it will be better device for humidity,
yes,
which is
yes,
really necessary for these days.
yes.
Okay, I understand.
Yes, yes.
Uh, During the transport purposes, you have given the correct question. That current degree by something and the divisions on the 500 and something. There, you are bringing the 1D calculation, isn't it?
Exactly.
1D.
Yes.
In 1D, that should be T and some M. In 1D calculation, what happened? That works as a step-like behavior. Okay, I think something that equation something is missing in my opinion. I don't know. Maybe.
I think
T3 or 52 slides, I don't know.
that is it is actually in the computational details.
No.
The parameters
no,
actually.
yes.
Parameters partner.
No, he's still in results
54 or
section.
53, 53. Yeah. No, not here.
53,
Equation of current.
Equation.
Yeah, current. 0.5 transfer.
56, 53, 54. No?
Yeah, nearby issue.
This is 53, this is 54. No. I have not written there. Current equation I have mentioned in the
Yeah.
parameters.
Okay.
Go back then.
This is the current equation.
Yeah, T by S and something that tau is only there is. Between that there is one factor should be there, I think, because it was as a that state function like behavior while the electron transfer.
It is sir, I will.
Because in the land road particular formula, if you look more accurately, and there that equation should be there some ME type of factor should be there.
Okay, sir, I will look into
Okay.
this.
Any more questions? So then I will ask one. I will ask. So continuing with Dr. Pinklay's question, see, you have water molecule, and when you have single water molecule, it's okay. But when you have multiple water molecules, you have to worry about another thing. What is that?
There's hydrogen bonding.
Hydrogen bonding. So how you are going to do that? Or how did you take care of that? Because you have several water molecules also. But can you take care of hydrogen bonding, bond breaking and making? Because whenever there is few water, you have the issue of hydrogen bond making and breaking. So did you take care of that? No.
Because we work on only the ideal case for the single molecule. We have not got for increasing the number of molecules.
So that you have written dopant concentration and all. So those things. Yeah. So now a second question is, how do you kind of identify which atoms or elements you are going to use for functionalization or decoration, whatever you call it? See, you have used two words. One is functionalization, one is decoration.
Yes.
First question is, what is the difference between them?
Actually, ma'am, functionalization means playing with your surface modification, right? If you do any of the modification in surface, it can also termed as functionalization.
Then what is the difference between decoration and functionalization?
Actually, I told Candee I have how I did functionalization. But one, I did it with doping, and second, I did decoration of your copper atom on the already functionalized, that is boron doped nitrogen.
So I can call it double functionalization. Who
Yes,
stops
yes.
you?
No, I don't know. It depends on the literature. This term decorated copper, that's why I have written decorated term. If
That means
double functionalization.
you are doing calculation and you are arriving at some conclusion. So if you are using different terminology like decoration, functionalization, so then you have to be clear what do you mean by functionalization, what do you mean by decoration. Okay. Next question is K point sampling 1/100. So this is for which kind of system?
Actually, we have one dimensional. When we take a field and extend to infinite, basically, to make more and more repetition, then we use this. So basically make it
So
one
for
dimensional.
three-dimensional, how many K points you will take? What will be your mesh looks like? Say if it is a simple cubic system, what will be your mesh? Uh, what will your mesh look like? Cubic system.
And I have to check for this.
No, you can tell me any number, but
Yeah.
you tell me any number. But for a cubic system, if I ask you to give me a K point sampling mesh, what will your number be? Any number,
Something
typical
like
number.
10 by 10 by 10 or 10 by 9
I
by
think
9 or something.
I think it should be 1 into 100.
No.
Because when you're doing
Here also yours is a one dimension, right? So in one dimension you have a long distance. In other two dimensions you have very short. So your K point sampling according to me is not correct.
Yeah.
So and for a cubic system, by now you should be ready with the answer. He gave the hint. It will be equal. Like 10 by 10 by 10 ho, yeah, 100 by 100 by 100 ho. It should be equal because your dimensions cubic system I say. So A equal to B equal to C.
But I thought we
No.
are going to transport calculation, so we extended one direction only. So the
No, listen carefully. Madam's question is
You are used for electron transport 1 by 100.
no, that's for electron transport only.
Okay.
And for this electronic properties and all, I use 9 cross 1 cross 1.
So
For
now,
two dimensions, I use
okay. Now I understand. Now you tell me like how you rationalize your 1 by 100.
Basically, ma'am, it is basically what we do when we do transport calculation. We take in which direction we want to see the transport properties. We consider that for that direction we consider higher K point.
Why? That is the question. Why?
I have studied this thing, but I don't remember right now. But I have studied in the educate tool. It is written there.
That is why. Why?
It
Of
is.
course, when I was asking about it, I was meaning the SCF only. That's what we were discussing. But now, since you say it is electron transport, you say 1 by 1 by 100
Yes,
or whatever number.
yes, no, I have read it. I have read that, but right now I don't remember this thing. But I have read this thing. कि Why we take this thing? Why we do 1 into 100? Because it gives more K points in one direction.
So that is not why.
That I have said, but right now I
Again, you are given a cubic system, so it should be like n by n by n. Now, if I give you a tetragonal system, which is A equal to B, not equal to C, C is smaller than A and B. So, how your K point will look like? Now, think.
Yes, I think that you will find answer for that.
अभी बोलोगे? सोच के बोलो. I said C equal to less than A and B. A equal to B equal to C,
Yes.
and not equal to C, and C is less than A and B. So then 10 by 10 by 10 say how your K point mesh will be modified.
C will be lesser. Definitely.
K point. Which space we are talking about? We are talking about reciprocal, na?
Yes, sir.
Chalo, ठीक है. Any more questions?
Good.
Yes. Now, what is enormous? Okay. So let us thank Monica for a nice talk and lot of results. But this kind of situation, like, it feels so sad. Nobody to ask questions. See? So, huh? They started using the poster. That is not nice. Then they are giving talk. Okay. So next speaker is in 8th Suman. So since we have one talk was missing, so you can use little more time.
Wow.
Like you also use more time. Don't worry, I am not giving you anything extra.
No, I'm not questioning about that.
So now let me check.
I'm thankful to you. You have asked me 2 more new questions so that I can find the results on that.
So you have 3. I think I asked 3 more questions. 2.
1 for K points and 1 is for this.
And hydrogen bond breaking and making. So you can take like 14 minutes for stop and then 2-3 minutes. For questions, actually, we will not stop. So, questions we will otherwise, but speak. Talk you have to finish by 14 minutes because that's we also do. And so you touch your main results, which you think more important. Okay.
So hello everyone, myself Harshika Suman, and I am here to present my thesis on the topic study for the treatment of candle influence by electrochemical methods. I did my PhD from MNIT Jaipur under the supervision of Dr. Vikas Kumar Sandal sir. These are the contents which I will present in this presentation. As we know, the way wastewater is more concerning topic nowadays. So, what is labor tanning industry is the most polluting industry in the world, and as you can see, the every production stage from the tanning process have released lots of waste water. As you can see, 34 to 56 meter cube of waste water from for the processing of the per ton of raw hide, and it generates a lots of effluent that containing organic matter, inorganic matter, COD, BOD, and chromium and sulfides and many more. And the quality of this wastewater depends on the types of the process used, types of the hides used for the tanning. As we can see from this figure, every process used in the tanning of skin, from the preservation to the stock, every step release the wastewater. As we can see from this table, this is the characteristics of the Candee flares. As we can see, COD and BOD values are too high, that is 5,000 mg per liter, which is very more from the permissible limit, that is 350 for the ground level discarding. And so for that, the tanning industry, for that, it is necessary to treat the tannery industry wastewater. So the conventional wastewater techniques are not suitable for this, because that the wastewater has biological index of this wastewater is too low, and that is not enough to meet the purity level. So for that, nowadays advanced oxidation processes are used. So what is advanced oxidation process? There is electrode are there, one is anode and the other is cathode. When electricity is supplied to the electrode, the hydroxyl radicals are generated, and these hydroxyl radicals are interact with the contaminants, and hence the destruction of contaminants. So AOPs are the four types: chemicals, photochemical, sonochemical, and electrochemical. Among these electrochemicals, AOPs are more having great attention, because it leads the total mineral. No secondary pollutants are generated. So, upon the vast literature survey, these research gap I have been found. The most important research gap is the lacking of the continuous study. Many of the researchers are conducted their study in the batch mode, and few only 2 and 3 researchers have conducted their studies in the continuous mode, but they have recycled their stream from outlet to the inlet, which is not feasible for the industrial purpose. So for that, from that literature survey, these are the objective we have decided for my PhD work, and this is the my thesis outline. Basically there is 3 study. One is model compound, and in the model compound study, I have used acid black 210 dyes and the acid yellow 210 dyes. These both dyes are extensively used in the tanning for the leather, for the dyeing of the leather. And second one is synthetic Candee fluids, and the third and major study is the real Candee wastewater. So we have conducted these 4 studies in the both batch and once through continuous mode. So as I said earlier, many of the researchers are conducted their study in the continuous, but they have recycled their stream. As you can see from that figure, this is the once through continuous system we have designed in our lab. From there, wastewater is supplied from the perspective pump by the perspective pump from the inlet in the reactor, and one time inlet and one time outlet from that. That means this is once through continuous reactor. And these we have used MMO electrode for as anode and stainless steel as a cathode. MMO electrode are the oxides of the titanium, ruthenium, and iridium. We have purchased this electrode from the Exotic Chemicals, Mumbai, and these studies are conducted to perform the parametric studies, degradation studies, kinetic studies, and energy consumption, and the operating cost analysis. So we have used the response surface methodology for conducting our experiment to reduce our experiments to do, and we use RSM BBD and RSM CCD we have used for the parametric analysis and the optimization analysis, and we have conducted degradation, COD, POC removal, and after that we have conducted percentage contribution of the factors, GCMS analysis, and the toxicity analysis. Both GCMS and toxicity analysis have been conducted for the disposability study, whether this treated wastewater is now ready for the direct discharge into the stream or not. So this is this is my first study, the treatment of the acid black protein dyes. We have used 3 input parameters: pH, current, and the time, and the 3 output parameters, that is percent decolorization, percent degradation, and the energy consumption. And we did many trial experiments, and after that we have we have decide and range of the variables, that is for the pH is 3 to 11, that acid to base, and the current is 0.5 to 2.5 ampere, and the time is 0 minute to 60 minutes. And these data are fitted to the given to the RSM surface methodology BBD, and that RSM BBD give us the 17 experiment to do at different conditions, and we have performed that experiments at this different conditions, and these are the results for that. The means 7 pH 60 times and 2.5 current. What is the color removal, energy consumption, and the degradation. And now we have to assess the model whether our fitted values or our calculated values is good or not. So we have to assess the model. So for that there are lots of parameters are there, but first we consider the R square value, which is our near about the 1, and second is the actual versus predicted plots. We can see from these figures the data points are lies between the diagonal line. That means our fitted model is good. Second is the p-values. P-values from this ANOVA table, and this is shown that our fitted model is very good, and this less than 0.05 value shown that our model is significant, and we have to insignificant the lack of fit value, and both the three results we have the insignificant value of the lack of fit. That means our fitted model is good. These are the 3D surface plots for the efficiencies with the variables. As we can see from this figure, as we increase the time, our color removal is increased, and the current is only slightly contribute to the color removal for this dye. And as we can see from this figure, when we increase the current and the time, the energy consumption is proportionally increased. That means the energy consumption is the directly function of the current and the time. As we can calculate study the parametric study from these figures also. And now we have to optimize our system. What is the optimum condition for these data? Ultimately, we have to optimize our study, and we have to give an optimum condition. This is the optimum condition, and we have most of the removal for this condition. So for that, we have applied two constants, that is for the color removal and degradation, it is in maximum condition, and energy consumption in the minimum condition. With this, we have found 35 minutes is the optimum time for the removal with the desirability with the 0.97 desirability function. Desirability is the parameter whether our model is good or not, or our optimum condition is good or not. Above 0.82, we have considered that our model is good. And at this optimum condition, we have performed an experiment, and the experiment results are near about the predicted one. That is 97% of color removal we have achieved with this optimum condition, with the energy consumption of the 6.3 kilowatt hour per meter cube. At this optimum condition, we have conducted other set of analysis, that is toxicity analysis, GCMS analysis. So from the toxicity bias analysis, we can see around the bore well there is zone of inhibition for the untreated wastewater, and after the treatment there is no zone of inhibition around the bore well. That means our treated wastewater is suitable for the discharge in the direct river streams. And same thing we have achieved in the GCMS analysis. As we can see, the untreated wastewater and the treated wastewater. The untreated wastewater contaminants are not mineralized, but it is minimized, and some intermediates are formed, that is dimethyl halide and the chloro compounds. That means there are some more need to directly discharged to the river water and something else. And with this optimum condition, we conducted the first two continuous study with the different flow rate. This is 5 ml per minute, 10 ml per minute, and 20 and 30. And with this, we calculated the degradation and deceleration study. As we can see, the deceleration is increased, and by the time of 35 minutes, it is achieved in the equilibrium. Means that इसके बाद वो treat नहीं होगा. That there are some intermediates are formed by the reactions or by the electrodes. These are the kinetic studies that have been performed for the color removal and the TOC and the COD also. So TOC stands for the total organic carbon and the COD stands for the chemical oxygen demand. So the major conclusion of this studies, we have successfully found the feasibility of this electrooxidation techniques, a technique for the treatment of acid yellow acid black protein dye, and we have also calculated the operating cost for this, and we have found $1.26 for treating the 1 meter cube of wastewater. Similarly, we have done the study for the acid yellow 1110 dye, and these are the parameters for that. This is the optimum condition for this. As we can see, the time is reduced. In 28 minutes, we found 93% of the color removal, and the energy consumption is very less. At these optimum conditions, we have performed also GCMS analysis, toxicity analysis, and the was to continuous setup. As we can see, the untreated wastewater gives us the zone of inhibition around the well, and the treated wastewater there are no zone of inhibition around the well in the treated wastewater. And this is the value. This is the profile for the waste through continuous setup at different flow rate. We also calculated the operating cost for this study also. $0.44 per meter cube of treated wastewater is the cost for the treating of this dye. Now we move for the second study, synthetic Candee wastewater. My biggest task for my PhD is the synthetic preparation of the synthetic wastewater. So finally, we have found two contaminants, that is 4-chlorophenol and chromium, for the preparation of the synthetic Candee wastewater. And these are the input parameter and the output parameters we have calculated for this. As elapsed times is nothing but the treatment time, and resident times is nothing but the flow rate. And these are the selected variables after conducting the many trials experiments. These are the results. The RSM suggests our 29 studies for this, and we have conducted 39 studies at these conditions, and these are the results for that. This is the actual versus predicted plot for that, and we have seen that our data are lies between the diagonal line. That means our suggested model is fit and good. These are the effect of parameters. As we can see from that figure, when we increase the pH, the chromium removal is decreased. That means acidic pH nature is good for the removal of the chromium. And when we increase the resistance time, that is flow rate. When we increase the flow rate, the contact time of the wastewater to the electrode is decreased. That's why the chromium removal is decreased. As we can see other parametric studies from the other graphs. This is the percent effect. This is the contribution graphs for this study for the chlorophenol removal, chromium removal, and the energy consumption. As we can see, the energy consumption is the time of the. It is the function of the time and the current. This is the contribution which parameter is more contributed to increase or decrease the efficiency or else. This is the optimization process condition for this, and we have found 56.9% of chlorophenol removal and 60% of the chromium removal with the energy consumption of the 63.89 kilowatt per hour meter. And we, at this optimum condition, we have calculated the COD and the TOC, and we performed the kinetic study for that, and we have found that both studies are fitted in the first order kinetics. We have calculated the operating cost for this also, and the operating cost are $6.12 per meter cube of treated wastewater. And we have found very good feasibility for the treatment of this. Now the major actually मैं काम कर रही हूँ तो इसका थोड़ा सा बताती हूँ. My major objective of my thesis is the
slides बाकी है.
sorry
कितना slides बाकी है?
मैं बस इसका थोड़ा सा बताती हूँ. For the real Candee wastewater, so we have collected a sample from the Candee industry situated in the Manpura Mancheri, and we performed the physicochemical analysis for that. And after the physicochemical analysis, we have performed the biological index analysis. If the biological index is less than 0.5, that means it is not biological treatable, and our biological index is 0.25. That means it is not biological treatable. Chemical reaction or chemical treatment is necessary for this. So this we have performed batch and continuous study for both for this real Candee wastewater. This is the batch treatment parameters, and we have not use pH as an parameter because we use an real Candee wastewater, and for the industrial feasibility it is not possible to change the pH according to the experiment. So these are the results for that, and we have performed the 270 minutes of this experiment with the 2 ampere current, and we have found 82% of the COD removal in the batch process. And similarly, we have done the once through continuous study for the Candee wastewater, and we have used 3 input parameters, that is current, resting times, and the elapsed times. And again, the resting times is nothing but the flow rate. These are the experimental design for the RSM CCD. These are 20 experiments are suggested by the RSM CCD, and these are the result for the efficiencies. And these are the actual versus predicted plot, and these are the effect of parameters for the COD and the energy consumption. As we can see, when the time is increased, the COD removal is increased, and we increase the current. Also, the COD removal is increased, but at a particular time there will be an equilibrium. After that, there is no COD removal because of the intermediates or an equilibrium. These are the optimum conditions for the continuous setup by the constraint COD in the maximum condition and energy consumption in the minimum condition. And we have achieved 58% of the COD removal. And we perform the kinetic COD, TOC, and the UV spectroscopy. From the UV spectroscopy, we have seen that in the visible region, almost all absorption is going to 0. That means our color is removed, and there is some intermediates are there in the UV region. That's why our COD removal is 58% only. And we can see from the TOC removal, in the 180 minutes, only 23% of the TOC is removed. And so that we can't say that this wastewater are ready for the direct stream, for discharge to the stream. So then we have calculated the biological index for that, and the biological index is upgrade to the 0.2.5 to the 5.1. That means it is now biological degradable. So we have concluded from this this process can be used as the pre-treatment for the integrated process, not for the fully treatment process. This is the operating post for this, and we have good findings with this. Now, future recommendations are we can go for as we can analyze the real-time wastewater treatment aspects. So we can go for the pilot plant study. We can go for the life cycle assessment. We can go for the integrated process for the calculating of the synergetic effect. These are the papers published during my PhD. These are the book chapter published in Scopus, and these are the international conferences I have attended and references. Now I would like to thank my supervisor and Dr. Anurag sir for guiding me in the immense help, and thanks to all.
Thank you very much. So now questions.
Some,
Yes.
yes, actually, I've seen some one slide, there is the either analysis part. Some first either analysis. Some means either part.
Error analysis.
Either part is there. Some are related plus minus 10 also is there.
Okay, yes.
How it is plus minus 10?
Actually, when we calculated the real-time wastewater
Yeah.
physicochemical analysis, so this is very crucial step for because the preservation of this wastewater is very tough task. We have calculated immediately all the experiment because the properties are changed during the time by the time. As we can see, if we see in water, then biological index are there. Some contaminants are there if you leave in water in the bottle. Then so that the plus minus part is there because इतना error हम जब करते हैं तो हमारे experiments में आ जाता है और 50% just like COD in 50 mg per liter. 50 mg per liter is not more. इतना हम जब हम कोई भी एक्सपेरिमेंट करते हैं हमारे वहाँ पे COD का भी तो हम उसको 3 बार करते हैं देन उसका हम लोग एवरेज लेते हैं कोई भी जो भी जितनी भी स्टडी यहाँ पे परफॉर्म की गई है उसका सबके जो जितने भी रिजल्ट्स हैं वो हमने 3 बार परफॉर्म किया और एवरेज रिजल्ट्स हम लोग स्टडी में पेपर में पब्लिश करते हैं दैट्स व्हाई दिस इज गिवन प्लस माइनस
सर का क्वेश्चन है थोड़ा वैल्यू कंडक्टिविटी का फॉर एग्जांपल 31.56
Yeah.
with a plus minus 10
Yeah.
it's huge.
Yes.
So these kind of error
सर वो एक्चुअली वो यूनिट का प्रॉब्लम है एक्चुअली में
यूनिट का
हाँ वो
problem
मैं
जो भी
हाँ वो थोड़ा सा हाँ मिस्टेक ले ली
नहीं वो भूल जाओ 31.56 is your absolute value and you are telling plus minus 10 okay so that
Sir,
is
वो
what
actually-
sir has observed
वो एक्चुअली जैसे सेंसर का था तो सेंसर इतना करता है बट वो यूनिट का प्रॉब्लम है एक्चुअली जो हमारा सेंसर है कुछ वो मिली माइक्रो में भी वो करता है तो वो जहाँ पे वो जो प्लस माइनस का एरर है वो माइक्रो में ये सीमेंस में है तो वो यूनिट का इशू है एक्चुअली बस वो थोड़ा मिस्टेकली रिटर्न हो गया उसको मैं हाँ बाकी सारे यूनिट्स
anybody else madam
ये आपका जो application है ये uses for ternary wastewater. So can this method can be applied for any other wastewater?
लोग कर रहे हैं अदर वेस्ट वाटर टेक्सटाइल इंडस्ट्रीज पे इसका बहुत ज्यादा यूज में आ रहा है बिकॉज टेक्सटाइल इंडस्ट्रीज में डाइज होती है एंड डाइज में कलर प्लस डिग्रेडेशन होता है एंड कलर रिमूवल इज वेरी गुड एंड बाय दिस प्रोसेस एंड जो बाकी जो प्रोसेस नहीं कर पा रही है दैट इज डिग्रेडेशन तो डिग्रेडेशन क्या होता है पर्सिस्टेंट पॉल्यूटेंट क्या होता है जो हमारे यूवी रीजन में होता है विजिबल किसी भी वेवलेंथ में यूवी रीजन विजिबल रीजन होता है तो विजिबल रीजन का जो रिमूवल है वो हर प्रोसेस कर पा रही है बट जो पर्सिस्टेंट पॉल्यूटेंट्स है वो होते हैं यूवी रीजन्स में उसको हर एक प्रोसेस नहीं रिमूव कर पाती है बट इलेक्ट्रोऑक्सीडेशन प्रोसेस जो है वो पर्सिस्टेंट जो डेटा है उसको रिमूव कर पा रही है तो इसको टेक्सटाइल इंडस्ट्री में सबसे ज्यादा यूज में लिया जा रहा है अभी इसको जो मेरे सुपरवाइजर है तो उनका ही काफी सारा काम है जो कि इसमें फार्मास्यूटिकल्स इंडस्ट्री में भी उन्होंने किया हुआ है सेम काम इलेक्ट्रोप्लेटिंग में भी ये चीज हो रही है एंड हमारा पेस्टिसाइड्स में भी ये चीज हो रही है बट हाँ कुछ जैसे पेस्टिसाइड्स हो गया, टेनरी हो गया, बहुत कम काम हुआ है।
So after treating this water, what will happen to that water?
जी, अगर हमने सिर्फ डाई वेस्ट वाटर लिया तो डाई वेस्ट वाटर इज गुड फॉर, हम छोड़ सकते हैं। बट जब हमने अभी रियल वेस्ट वाटर इसको लिया तो रियल वेस्ट वाटर इज द कॉम्प्लेक्स वेस्ट वाटर, वी कैन, हम लोग हर किसी प्रोसेस उसको नहीं ट्रीट कर सकते, बट हमने ये किया। अब वहाँ पे बायोलॉजिकल इंडेक्स का सबसे बड़ा मैटर होता है, बायोलॉजिकल इंडेक्स होता है बीओटी बाई सीओडी रेशो। तो बीओटी बाई सीओडी, कोई भी जो कन्वेंशनल प्रोसेस है बायोलॉजिकल मेथड से, वो 0.2 0.5 से ज्यादा होगा तभी वो उसको ट्रीट कर पाएगी, उससे पहले वो ट्रीट नहीं कर पाएगी। इसके लिए आपको केमिकल प्रोसेस यूज में ली जाती है। तो केमिकल प्रोसेस एज आप इलेक्ट्रोऑक्सीडेशन, इलेक्ट्रोफेंटोन, इलेक्ट्रोकोगुलेशन, आप कुछ भी यूज कर सकते हैं। बट द इलेक्ट्रोफेंटोन का डिसएडवांटेज ये है कि वो आपके सिर्फ एसिडिक में ही काम करती है। इलेक्ट्रोकोगुलेशन का डिसएडवांटेज ये है कि उसमें एक स्लज बनता है और वो स्लज को ट्रीट करना ज्यादा डिफिकल्ट है। अदर देन हम किसी भी वेस्ट वाटर को अगर ट्रीट कर रहे हैं बाई चांस कोगुलेशन से कर रहे हैं, सिंपल कन्वेंशनल प्रोसेस है कोगुलेशन, तो कोगुलेशन में क्या होता है, स्लज जनरेट होता है। अब स्लज जनरेट होने के बाद उस स्लज को ट्रीट करना ज्यादा डिफिकल्ट है। बट मोस्ट ऑफ द इंडस्ट्री अभी भी सारी चीजें यही पुरानी ही यूज में ले रही है। कुछ जगह पे अभी इलेक्ट्रोकोगुलेशन को इन्होंने अडॉप्ट करना स्टार्ट किया है, बट उसमें भी एक दिक्कत ये आती है कि वहाँ पे हमें इलेक्ट्रोड्स लेने पड़ते हैं आयरन के, तभी वो इलेक्ट्रोकोगुलेशन होता है और इलेक्ट्रोड की फिर वहाँ पे फाउलिंग होती है। और इसका डिसएडवांटेज भी है, डिसएडवांटेज ये है कि जो इसके जो या तो हम लोग खुद इलेक्ट्रोड्स बनाएं, क्योंकि इसका इलेक्ट्रोड मैन्युफैक्चरिंग बहुत ज्यादा महंगी है और इलेक्ट्रोड फाउलिंग इसमें बहुत कम होता है, ये इसका एडवांटेज है। और एडवांटेज ये भी है कि इसमें स्लज जनरेट नहीं होता है, तो डायरेक्ट ये पॉल्यूटेड एयर में हमारा ट्रांसफर होता है, तो हमारा कोई सेकेंडरी पॉल्यूटेंट जनरेट नहीं होता। तो इसलिए मैंने ये वाले प्रोसेस को ही किया है। मैंने इलेक्ट्रोफेंटोन भी किया है बाय साइड प्रोजेक्ट सर का।
So water treat होने के बाद क्या है?
हाँ, वाटर ट्रीट, सॉरी। तो ये जैसे हमने 58% हमारा हुआ, बट 58% तो हम फिजिबल नहीं है, क्योंकि जो हमारी पॉल्यूटिंग जो परमिसिबल लिमिट है वो सीओडी की है 350 ppm, ठीक है। तो 58% में यहाँ पे इसका इनिशियल सीओडी है 3570, तो 58% से ये 1600 समथिंग आएगा, तो इसको हम नहीं छोड़ सकते। बट यहाँ पे चीज क्या हो गई है, बायोलॉजिकल इंडेक्स हमारा 0.5 कम हो गया है, तो मैंने कंक्लूड भी यही किया है कि हम इसको एज अ प्री ट्रीटमेंट, आजकल इंटीग्रेटेड प्रोसेस ज्यादा यूज में की जाती है। इंटीग्रेटेड प्रोसेस का सबसे जो मेन एडवांटेज ये है कि हमारा टाइम कंजम्पशन जो है वो मिनिमाइज हो जाता है। तो इसको एज अ प्री ट्रीटमेंट हम यूज करके बाकी कोई दूसरे प्रोसेस को हम यूज करके इसको फुल्ली मिनरलाइज करके इंडस्ट्री में छोड़ सकते हैं। और बाकी मैं इस जहाँ से वेस्ट वाटर लेके आई हूँ, तो वहाँ पे अभी भी जो कन्वेंशनल वेस्ट ट्रीटमेंट है वो वहाँ पे हो रहा है। मैंने ये क्लेश बेसिन से वहाँ से उठाया था।
So I have a few questions. What is? Can you go to page number 31? 31, 30. So this, did you fit this straight line you got r square equal to 0.9698 etc.
Yeah.
Yes, sir.
I think here.
Which kind of software you have used?
For this fitting,
Yeah.
Excel. But we have plotted the horizon.
Yeah, but you see, r square means what? Tell me that r square means what?
The fitting here, fitting
Yes.
R square, that straight line fitting. And we,
For example, 0.9698. This
you can fit this with this value in the horizon. I have found this.
No,
value.
0.96, that should be accurate. Huh? That should join the all points.
So it should be close to that.
Yeah,
Yeah, and then I think slide number 39, can you go? And of course, here just stop. No, just stop in that. So here I have a suggestion for you. You started telling many different abbreviations like COD, TOC. I have no clue because I am not from your field. So I did not know until quite a few slides away I came to know what do you mean by COD or TOC, etc. So you have to, if you are using so many, abbreviations, and with this kind of platform, then you should give a glossary. This means this, so that people can go back on this. 39, can you just go? Here, for example, experimental value. Okay, so experimental value, you say percentage CO2 removal, experimental 58.63.
60.
You go to second decimal, there is no error
Plus
bar.
minus.
Plus minus.
Hmm.
So, how do you arrive at that kind of value?
Actually, ma'am, this is the predicted value.
The predicted, therefore you have done some model calculation or whatever. I am talking about experimental value.
Actually, मैम हमने इसके भी हम लोग 3 एक्सपेरिमेंट हमारे ऑप्टिमाइजेशन के लगते हैं. तो 3 एक्सपेरिमेंट में हमारा सिर्फ 58 नहीं आया, हर किसी में कुछ ना कुछ एरर आती है बिकॉज ऑफ द एनवायरनमेंट और बिकॉज ऑफ द इंस्ट्रूमेंटेशन एरर. तो हमारा ये जैसे मैं इसका मुझे याद है कि इसका एक बार आया था 57, है ना, कुछ एक बार कुछ और. तो हम लोग एवरेज वैल्यूज की लिखते हैं, बट यहाँ पे मैंने उसका एरर बार नहीं लिखा क्योंकि मुझे यहाँ पे प्रेडिक्टेड के साथ उसको ये करना था कि हमारी जो फिटेड वैल्यू है विद दिस ऑप्टिमम कंडीशन इज गुड, क्योंकि हमारा ये नियर बाई आ रहा है. और
see, that is what you are talking about, nearby values. 59.41 is some calculated value.
yes,
Now I am talking about not only, I am just identifying one particular value. It is true for energy consumption and
Yes,
many
yes,
other
yes.
things also. So you are calculating something and then you are doing experimental, showing experiment, and you say very good matching. But you have taken only 3 experimental measurements. In principle, so you should have taken many of them and then average. If you are averaging and getting this number, so then you, and there also you should have given plus minus first of all. And if you are doing this, then you should have done many experiments and then only come to an average value. Na? Otherwise, so this, first of all, you have gone to up to the second decimal, no error bar. So that is a little bit this thing. And there was some, probably 11 or so. Can you just go back? Most likely 11, I don't remember now. There are actually many questions, but I am just picking out few.
एक्चुअली हम टाइम कम था तो मैंने
time कम
आधी
था, वो तो
चीजें
सही
उसकी
है।
स्किप कर दी और आधी स्लाइड्स ही हटा दी थी मैंने.
वो तो सही है. Here, just a minute. Here, I had some question. Here I could not figure out. You were talking about variables. Okay. Initial pH, then range of actual and coded variables 3, 7, 11. So what do you mean by these 3 columns? Like current 0.5, 1.5, 2.5.
एक्चुअली हमने यूज किया RSM, BBD और CCD मेथोडोलॉजी. उसमें क्या होता है, हमें इनिशियली हमें वेरिएबल्स की वैल्यू देनी होती है कि हम लोग इस रेंज से इस रेंज तक हम जाना है.
मेरा क्वेश्चन इसलिए है, फॉर एग्जांपल इफ आई टेक फैक्टर A initial pH 3, is it that the current B, factor B current I is always associated with 0.5 or you have varied 0.5, 1.5, 2.5? That's what my question is.
एक्चुअली जैसे अगर हम लोग विदाउट सॉफ्टवेयर हम लोग एक्सपेरिमेंट परफॉर्म करते हैं तो हमें काफी सारे एक्सपेरिमेंट्स हमारे आते हैं. तो उसकी जगह हमने एक्सपेरिमेंट्स को मिनिमाइज करने के लिए हमने क्या लिया, सॉफ्टवेयर. तो उस सॉफ्टवेयर में क्या होता है कि हमने 3 वेरिएबल्स उस पे कोडेड है. जैसे हमने बीबीडी लिया तो वो 3 लेवल तक कोडेड होता है. अगर हम सीसीडी लेते तो 5 लेवल तक कोडेड होता है. तो हमें उसकी 5 लेवल और 3 लेवल की कोडेड वैल्यू देनी होती है. फिर ये इसका मिक्स करके हमें एक्सपेरिमेंट की वो देता है कि आप इस इन कंडीशंस पे हमें एक्सपेरिमेंट की वैल्यूज दीजिए. जैसे कि अभी आपने बोला कि 0.5.
That means you go back. That means your factors A, B, C, and these are just few values of A, few values of B, and few values of C, and then you are mixing everybody.
मिक्सिंग
हाँ, तो वो क्लियर नहीं हुआ. मैं सोचा कि इसी कॉलम का कॉरेस्पॉन्डिंग दिस, इसी कॉलम का कॉरेस्पॉन्डिंग दिस, ऐसा.
नहीं, वो एक्चुअली जो इनसे पे काम करते तो उनको आता है, इसलिए मैंने
आपको कैसे बताओ? अच्छा, तो 11 हुआ. और एक
मुझे लगा आपका क्वेश्चन ये है कि हमने 0 मिनट क्यों लिया.
नहीं, 0 मिनट तो यू स्टार्टिंग में देखा, फिर 30
नहीं, एक्चुअली जैसे इसका भी एक रीजन है 0 मिनट लेने का कि जब डाई का हम लोग रिमूवल करते हैं तो वहां पे जब हम जैसे हमने उसका पीएच चेंज किया, कुछ ना कुछ डाई रिमूव हो जाती है. जस्ट लाइक हमने अगर डाई वेस्ट वाटर को हम लोग गाढ़े दूध में रख देंगे तो वो वहां पे डाई का कहीं ना कहीं पहले 2% उसका रिमूवल होगा, बट होगा, इसलिए हमने उसको 0 पे लिया है। अगर आप कहीं और देखेंगे, जैसे अभी मेरे और रिजल्ट सिंथेटिक्स वाले में अगर आप देखोगे तो वहाँ पे 0 मिनट नहीं है, वहाँ पे हमारा टाइम स्टार्ट हो रहा है 30 मिनट से, क्योंकि एक हमें जो रेंज है किसी भी ट्रीटमेंट की वो हमें किसी टाइम के बाद ही देखने को मिलेगी, ये वाली रेंज, क्योंकि जो सॉफ्टवेयर है वो रेंज समझता है, वो ये समझता है कि 0 से लेके हमारा 30 मिनट तक इतना, अगर 30 मिनट में हमारा इतना रिमूवल हुआ और फिर हमारा जैसे 150 मिनट में इतना रिमूवल हुआ, देन वो आपको ये वाले ग्राफ प्रेडिक्ट करके देता है।
And just go to this treated and untreated water. Last question, because I have several questions, but treated एक just picture दिखाओ, picture वाला जो treated and untreated का।
अच्छा, GCMS।
हाँ, ये चला गया।
हाँ,
इसमें तुम कुछ बोले थे।
यस,
इसमें क्या दिखता है?
एक्चुअल में क्या होता है मैम, यहाँ पे ये होते हैं इक्विलाइब्रेट आकार प्लेट होती है, एक ये स्टैंडर्ड मेथड है टॉक्सिसिटी एनालिसिस का, ठीक है। इसमें क्या होता है, एक आकार प्लेट होती है, इसमें हमें जो है अलग अलग तरीके से कर सकते हैं, बट हमने इक्विलाइ बैक्टीरिया से इसको किया है। इस पर इक्विलाइ बैक्टीरिया स्प्रेड हुए होते हैं, वहां पे हम लोग एक बोल क्रिएट करते हैं, इसको वेल बोलते हैं, इसको बोर वेल बोलते हैं, इस वेल क्रिएट करते हैं। इस वेल में हम लोग जो हमारा ट्रीटेड वाटर है और अनट्रीटेड वाटर है जो भी है व्हाटएवर, उसको हम लोग डालते हैं। उसके बाद हम इसको 24 घंटे इसको रखते हैं, फिर हम देखते हैं कि वो इक्विलाई के बैक्टीरिया हमारे मर गए या जिंदा है। अब हम जैसे अनट्रीटेड वाले में देख रहे हैं तो इसके जो अराउंड द वेल है तो ये बैक्टीरिया मर गए, ये नहीं ग्रो कर पाए, बट इसमें जो ट्रीटेड बेस्ड वाटर है इसमें ये मैं ग्रो कर दिया, जस्ट लाइक इसमें भी आप देख सकते हैं जो ये वेल है इसके अराउंड जो बैक्टीरिया थे वो मर गए, वो ग्रो नहीं कर पाए, और जो ट्रीटेड बेस्ड वाटर आया तो वो क्लीन हो गया। दैट मींस अगर हम इसको स्ट्रीम में छोड़ेंगे तो इक्विलाई बैक्टीरिया हमारे हेल्थ स्ट्रीम में आता है, तो सिर्फ इक्विलाई की बात नहीं है, एनिमल्स और भी होते हैं, फिशेस होती है, टॉक्सिसिटी एनालिसिस हम काफी तरीके से कर सकते हैं। मैं पहले इसको फिशरी एज अ फिशरी मोडेलिटी रेट से करने वाली थी, बट समहाउ वो एनिमल राइट्स वाला चीज से भी नहीं कर पाए, इसको मेरे पास टाइम नहीं था, तो हमने इक्विलाई बैक्टीरिया से कर दिया। हमने इक्विलाई बैक्टीरिया से स्प्रेड करके, और हम लोग ऐसे भी कर सकते हैं कि हम लोग यूवी स्पेक्ट्रोस्कोपी से कर सकते हैं कि हमने ना 3 ml या 5 ml हमारा वेस्ट वाटर लिया, उसमें इक्विलाई के बैक्टीरिया डाले, अब हम उसको 24 घंटे बाद देखेंगे कि वो इक्विलाई के बैक्टीरिया हमारे ग्रो हुए हैं या वो नहीं ग्रो हुए, वो हम किससे देखेंगे, एब्जॉर्बेंस से। अगर हमारे इक्विलाई के बैक्टीरिया बढ़ गए तो ऑब्वियसली हमारी एब्जॉर्बेंस बढ़ जाएगी, क्योंकि उसमें इक्विलाई के बैक्टीरिया आ गए। ऐसे हम टॉक्सिसिटी एनालिसिस हम फिशरी से भी कर सकते हैं, फिशरी मेथड से। फिशरी मेथड से कैसे करते हैं कि हमने 100 मछलियां ली, ठीक है, 100 मछलियों को पहले हमने उसको स्टेबल किया हमारे एनवायरनमेंट के हिसाब से 2 या 3 दिन, फिर एक जैसे कि हम लोग एक डाइल्यूशन फैक्टर लेते हैं, क्योंकि हमारा जो वेस्ट वाटर है, मान लो हमारा वेस्ट वाटर एक बाल्टी लिखा, लेकिन जैसे वो स्ट्रीम में जाएगा वो कितने हजार गुना से डाइल्यूटेड हो जाएगा, तो हम लोग उसको डाइल्यूट करते हैं हमारे लैब में, फिर उसको फिशरी वो जो फिश है उसमें डालते हैं और वो वेस्ट वाटर डालते हैं, वो अराउंड हमारा बहुत सारा लीटर का होता है, 50-100 लीटर का हमारा एक टैंक बना होता है उसमें, फिर उसमें ऑब्जर्व करते हैं कि मछलियां कितनी जिंदा रह पाए, कब मर गई कब नहीं मिली, तो हम लोग 12 घंटे का, 24 घंटे का, 72 घंटे का, 48 घंटे का हम लोग उसकी मोर्टेलिटी रेट देखते हैं। तो ऐसे में हम लोग टॉक्सिन, क्योंकि अल्टीमेटली हमारा पर्पस क्या है, इसको हम स्ट्रीम्स में छोड़ना, ठीक है, तो स्ट्रीम्स में ऑब्वियसली हम लोग पीने के साथ जीव जंतु भी रहते हैं इसमें, तो वो डाल दे तो मर जाएंगे, तो हमारा पर्पस इसको करने का यही है कि टॉक्सिसिटी हम उसको देख रहे हैं।
ठीक है, थैंक यू वेरी मच।
थैंक यू।
तो अभी तो पोस्टर सेशन शुरू हो गया।
यस
वैसे तो नहीं ना,
थैंक यू सर।
Thank you.